Review a generative model. In this video, we'll explore a 3D model and we'll create a distributed design. In Fusion 360, we want to get started by uploading the supplied dataset, generative frame outcome 1, and also make sure that we have our generative design geometry setup open. The generative design geometry setup was the one that we used to create our generative design study, as well as have our explore results. But when we create a 3D design from a generative outcome, it creates a brand new design. This is external and not linked to the original in any way. What we want to do now is we want to explore our generative frame. We want to understand what geometry we have and how we can work with it. And then we want to make a distributed design by putting it back into the original assembly. First, you'll notice that the orientation of the frame seems a little odd. And that's because the original design was modeled in the Y-up orientation. However, the default orientation for Fusion 360 is Z-up. So when we open the design and we take a look at it in here, it just simply appears to be at the wrong angle. This is perfectly fine, and I don't suggest that you modify the orientation of the frame, but if you want to manipulate the view cube, we do have the option to change how the view cube is oriented. For example, if we go to this back view, we can set the current view as top. This will reset the view cube, so when we go to home, you'll notice that it's in this orientation, but if we rotate around to the top view, it'll show the top of the frame. We also want to make sure that we reorient the front view of the frame. So we'll go to the right view, set current view as front, and now when we go to our home position, you can see that the home position is still based in the Z-up orientation. So we need to go to an orientation that makes sense for our home position. So we'll look at it from the left, then we'll click the upper left corner of the view cube, and then we'll select Set Current View as Home, Fit to View. Now, anytime we change the view and we go back to home, all the orientations should be correct. When we explore this design, you'll notice that we have this nice organic shaped frame, but there are some areas where we have these smooth cuts out of it. These smooth cuts are a product of having the obstacles that we created simply cut and removed from the design. This is exactly why it's a good idea for us to have our obstacles be a little bit larger. So when we come back into the design workspace, we can simply omit the exclusion or the cut of those different bodies. Now, there are some bodies that must be cut at a specific position. For example, the mounting position for the frame to the engine. However, there are other areas, such as the rest of the inside of the frame, that really doesn't need to have that material cut away. And in fact, a smooth transition rather than having these cuts is likely going to be a stronger option. But let's take a look at the timeline and see what comes in with a 3D model. I'm going to roll this all the way back to the beginning and take a look at the first base feature. The first base feature is based up of all the preserved geometry. We have our lugs on the engine, we have the upper portions for our shock, and then we have the steering stem. If we take the timeline marker and drag it a little bit farther forward, now you can see we have all of our obstacles. These are all things that get removed using what's called a boundary filled feature. If we go forward a little bit more, now we see the organic frame that's been created. I'm going to select and hide all of the preserves and obstacles by right-clicking and selecting Show Hide. You'll notice that the body that was created is a surface body. If we take a look at it, it's open on the inside, and it doesn't contain all of the mounting points or the lugs that we need to actually mount our frame. And that's because it uses this boundary fill feature to add those solid bodies and the surface of the frame together in one single solid body. Then it uses this combine feature to come back and remove those extra overlaps from those obstacles. So it's very easy for us to simply get rid of that last combine feature and put back all those smooth transitions in the frame. These are areas where we can keep those obstacles and we can use form tools to ensure that we are not violating any space that needs to accompany some other equipment like an airbox or exhaust. So now that we've seen exactly what we get from the timeline, let's go ahead and save the design. And let's navigate back to our geometry that was used to create this in the first place. So here we have the engine and the rear shock, we have our suspension, we have an image of what the motorcycle looks like in its stock form. We're going to expand our data panel to the place where we have our generative frame outcome. And once that has finished saving, what we're going to do is drag and drop it into our generative design geometry setup. Now remember, our design had the Y up orientation. And this original design has Y up, so the frame is put in the exact correct position. I don't have to move it at all. I simply need to select OK. And now I can take a look at the frame, how it would be situated around the engine, how it would deal with the suspension, and how it deals with the front end. We can see the original frame behind it in the image, and you can see that it has these triangular truss sections as well. So this is a very consistent design with how the original frame was built. We have the supports where we need it, and there are some additional modifications that we can make, but it does help us validate the truss frame setup, making sure that it does fit in line with the design aesthetics that we're going for, as well as all the performance that's needed. Once we've added the frame to the original assembly, let's make sure that we do save this. And any changes that we make now to the frame can automatically be propagated into this assembly because they are still linked together. Keep in mind that saving a design that contains an external link will automatically make an F3Z archive file. This is something that takes a little bit longer to zip up and convert. So keep in mind that if you are trying to export this or share this with somebody, that having an external link to that frame can be problematic. But we can always right click and break the link, and it will bring all of the different features that were used to create the frame directly inside of our assembly. From here, let's minimize the data panel and let's keep both the generative design geometry setup assembly open as well as the generative frame itself before moving on.